Okay, in this last part of the podcast about graphing transform sinusoids, we're going to talk about how, when you have the graph, how do you come back and get the equation? The upshot is you're going to try to, from the graph, find those critical pieces of information. You want to find the sinusoidal axis, you want to find the amplitude, you want to find the period, and you want to find the phase displacement, and you want to use those for pieces of information to then reconstruct the equation of the sinusoid. One thing I want to point out is that there's actually multiple equations that give you the same graph. If you have an equation, there's only one graph that goes with it, but if you have a graph, you can come up with a number of equations that will give you the same graph. Let's go ahead and talk about how we can come and figure these things out from the graph. Let's start with the sinusoidal axis and the amplitude. The amplitude is actually the best thing to start with, because if I look at this graph, I know that the amplitude is the distance from the middle of the graph to the top, or the middle of the graph to the bottom. It's sometimes not easy to tell where the middle is, but the top, it's certainly easy to tell where the top is, and the bottom, it's certainly easy to tell where the bottom is. So I know from the top to the bottom, in this case, it's 2 minus -8, which is a total of 10 units tall, right? So 10 units tall is telling me that that's the middle to the top and the middle and bottom together. So half of that is going to be the amplitude, right? So the middle to the top, this is the amplitude of 5, and the middle to the bottom, this is the amplitude of 5 as well. When I put that together, that also lets me know where the sinusoidal axis is. It's where the middle from the top to the bottom. In this case, it's going to be at -3, right? So we've got those two things down. The sinusoidal axis is -3, and my amplitude is 5. Now, let's not worry about the equation right now. I know that the period is confusing. Let's just get the period off of the graph here. Now, the period, remember, is the number of degrees it takes to complete one full cycle of the graph. Now, how do I figure that out? The easiest thing to do is to go from critical point to the next time that same critical point shows up. In this case, an easy critical point to use is the point where it's at the top of the graph. So here it's at the top of the graph at 10 degrees, and then here it's at the top of the graph again at 130 degrees. So that's telling me that 130 minus 10 is 120 degrees, is the number of degrees it takes to complete one full cycle. That number is the period. It's 120 degrees. Now that number is not going to go in my equation directly, but let's not worry about that yet. Let's just get the critical information. Now the phase, this is the part where you have some leeway as far as whether, do you think that this is a cosine graph? Do you think that this is the sine graph? This is where you can have more than one right answer for the equation. Let's go ahead and say that this is a cosine graph. The reason I want to do that is that it's really easy for me to tell on this graph where the critical point where cosine originates is, right? Remember that the parent function of cosine looks like this, right? It starts at the maximum, right? So if I know that I'm looking for the critical point that's at the peak, right, that's telling me that if I know what the x value is there, that's going to be d for a cosine graph. So here, my first peak is at 10 degrees. That is going to be my value for d for a cosine graph. I would have a different value of d if I wanted to do a sine graph, right? Where does it cross the sinusoidal axis? That's where a sine graph begins, right? Sine graph looks like this, is in the middle on the way up. Well, where does that happen? It would be here at -20 for a cosine graph, so -20 for sine. Now, you don't have to do both of those. You can do one or the other. We're going to go ahead and do cosine, but we can write an equation for sine if we want. How do I put these things together? Well, I have these pieces of information, and I need to put them together to make an equation. Let's start with the general parent equation. Y equals c plus a sine, or cosine. Actually, we decided we were going to do cosine b times the quantity theta minus d. Now, 3 of those 4 letters I can just fill in directly from the observations that I've made here. I'm going to go ahead and erase this sine graph, so I have a little bit of room down here. C, A, and D, I'm just going to go ahead and fill in. Y equals C is the sinusoidal axis, -3, plus A is the amplitude, which is 5. Cosine B, I'm going to leave as B for now, times the quantity of theta minus the phase, which for cosine was 10. So I know that I have all that, and then how do I figure out B? Well, remember this equation that the period is 360 divided by b. Well, you can solve that equation if I know the period and I want to find b, right? So my period is actually 120. 120 is 360 over b. So what does b have to be in order to get 120 as the answer? B in this case is 3. I could also, multiply both sides through by b, right? 120b, if I did not find that obvious, 120b equals 360. B equals 360 over 120. This formula actually will always work to find b. If you take 360, the natural period, and divide it by the observed period, it will always give you b. Okay, so in this case, b is 3 to give me a period of 108 or 120 degrees. I'm going to go ahead and erase b and replace it with what I know b to be, which is 3. Another version of this equation that would be equally correct would be y equals -3 plus 5 sine 3 theta plus 20, right? Because theta minus -20 is theta plus 20. Those are both valid equations for this sine wave, and hopefully you will find this as an easy way of going from the equation or from the graph to the equation.